All right, so yeah, I'm trying to be really like hard nosed about deadlines because I know at other
I
schools
didn't tell her because I sent
you
her
don't
an email
necessarily
and she
get
said, oh,
like
good.
grace periods and stuff. But if you did all the work to do the lab anyway, I want you to get credit for it. So that's why I soften sometimes, but not on lab 3. Okay, so lab 3 I'll enforce the deadline. So any issues with lab 2? Multiple times? But you got it in the end, right?
Yes.
Okay. I don't know why it stopped letting you log in at some point, but these things happen. All right, so did everybody confirm they know how to do addition? Cool. Good stuff. It's not really putty though, it's just mini-con. Alright, let me boot up my personal Pi. And let's talk about lab 3. Because I don't want you to be labless over the weekend. So lab 2 was dealing with output. You were lighting up LEDs. Lab 3 deals with input. So we're reading from switches. So you're going to interface your Pi to a couple of switches. And your switches look like this. They're little push buttons. They're not the dip switches that we use in the other labs. They're just off or on push buttons. They're more fun to play with. And these switches, electrically, they look just like the dip switches. They either make contact or they don't make contact. So when you're not pressing it down, the two sides are disconnected. When you press it down, this flips down and connects the two sides. So you're used to that. The trickiest part of this is these little switches have 4 legs on them. And you got to figure out which legs are which. So grab yourself a multimeter and figure out how these switches work before you go crazy trying to get your code to work, right? So 2 of these are connected to each other, and 2 of them are controlled by the push button, okay? So figure that out. The second most tricky part of the whole lab is that these switches, the little legs on them are kind of crinkly. It's a little hard to see. But you may need to, get a pair of pliers or use your nail or something and try to make these legs kind of straight so that they fit into your proto board. And I think we got a bag of 500 of these, so they're not super precious, but I don't know where the bag is, so they're a little precious. But if you don't have a switch in your parts box, or if the legs break off or something, let me know or let Azad know and we'll get you more switches. All right, so we have the ability to make or break connections between 2 wires. So here, these 2 wires are being connected or disconnected by the switch. All right, so what the heck are we doing in this lab? So there's some light text you can read here to explain what we do in order to read from these ports. But basically there's 2 commands, GPIO space mode space, and then the number of the port you want, 4 or 5 space, and then the keyword in. Okay, and if you do that, it says, okay, GPIO pin 4, for example, is going to be an input port. And then if you were to say GPIO read 4, the command will print out a 1 or a 0. All right, but we never want to connect a voltage source to any of these ports on the Pi. We can connect ground, but don't ever connect 5 volts. So remember what we do if we want to wire a switch. So this goes to the circuit. So let's see if you remember. How do we wire this up? Well, I'm going to make it
You have resistors.
harder on you. Add resistors. Where do we add resistor?
we add a resistor before it goes in?
So here or here?
Left side?
Left side. And resistor goes to
Ground?
and then anything else?
I'm sorry, it's been a while.
That's okay. So other ideas, because there's about 8 ways to try this, and one of them works, one of them kind of works, and the others don't. Does anybody else? Okay, let's go after the switch to ground. And then 5 volts. Well, forget that we're going into a pi, right? So this will kind of work. It's not ideal, but it will sort of generally work. The downside to this is that if you throw this switch, you've got infinite current going through this line, right? And that's the part that can damage not our 250 or 270 circuits, but the circuits in here. So the usual way would be something like this. So that by default, we've got 5 volts, but going through a resistor, so we've got 5 milliamps max going in, which will still blow some computer chips inputs. But then if we close the switch, this gets pulled down to ground. And there's no resistance then, but there's no current flowing either, so that's okay. So this is usually how we build the stuff in 250, 270. I have no resistors on here. I have no connection to 5 volts because the Raspberry Pi will do this for you internally if you ask it nicely. It will connect your input through a resistor to 5 volts. So that all you have to do is supply this part. Just a switch which either connects that input to ground or it doesn't connect it to ground. So this is called a pull-up resistor, right? Because it's pulling up the input through a resistor. So we can ask the Pi to actually put a pull-up resistor for us internally. And we do that by using the following command, GPIO mode 4 up instead of mode 4 in. And this says pin 4 should be an input, but it should also have a pull-up resistor. So let's, I think my blue wire is pin 4. So let me disconnect that. And my black wire is ground. All right, so this is ground, and I believe this is pin 4, but we'll find out shortly. So let's try this. Let's say GPIO mode 4 input. GPIO read 4, and it tells me pin 4 is at a 0 because I'm not doing anything with this wire. Okay. Now if I say GPIO mode 4 up, and then I read pin 4, now it's a 1. Okay, it's a 1 because there's a little resistor inside this box pulling that input up to 5 volts. Now, if I short these two lines together so that that input is connected to ground, assuming I actually got the right pin, now when I read it, it's a 0. And if I break that connection, it reads as a 1. So we can hook this up to a switch, and our switch doesn't need to be able to send 5 volts or 0 volts. It simply needs to be able to make or break a connection. So right now the switch is open, so it's reading a 1. If I press this button, it reads a 0. So that's how you get into the Pi from the outside world.
So is GPIO read only echo, or does it also return it as the exit code?
I think it only reads. Yeah, so it's always going to return an exit code of 0. So how do we get this into a variable so we can put it inside if statements and stuff?
Backwards?
Back quotes, right? So there's a reminder in here that if you put that GPIO read command inside back quotes, whatever value it returns, that will be the value of this right side of the assignment statement. So if I say pin 4 equals back quote that read, then pin 4 will get set equal to either a 0 or a 1. So let's try that. Right, so that just read pin 4 and it said it was a 1. And if I press this and I set pin 4 equal to that, then pin 4 is a 0. So GPIO mode 4 up conditions the input port, and then something like variable name equals back quote GPIO read 4 reads the value of that pin, loads it into that variable. And now you just write bash, right? You do whatever you want to do with that input. And we can do the same thing on pin 5, which is going into the next port on this board. All right, so there's more words in here than there need to be. So there's the pull-up resistor. So to recap, use GPIO mode number up. GPIO read number gives you the value on the port. And if you connect it to ground, you'll see a 0. Otherwise, you'll see a 1. All right, and here's your reminder about putting that in a variable. And so wiring the circuit is very straightforward, right? So we talked about the switches. And your circuit is going to more or less look like this. So this side of each switch gets connected to ground. And ground is on pin 20. And you're going to have two switches, and we're going to think of them as up and down. Do I tell you which is which? Okay, so up is GPIO 4, which is pin 16. So this is up. This is pin 16. This is down. All right, there's your whole circuit. 2 switches, 3 wires.
We don't need resistors.
Don't need resistors, don't want resistors. All right, that pull-up resistor to 5 volts is inside the Raspberry Pi now. So your circuit shouldn't take you, the hardest part of building the circuit is going to be getting the switches to go into the proto board. Once you do that, you're done wiring. All right, so what are your experiments? You got 4 experiments. The first one is what we already did, right? Hook this circuit up, condition your 2 inputs from the command line, and then do some reads. And when you press the button, you should read a 0. When you release the button, you should see a 1. That's just making sure you got your switches hooked up, you got your ground connection hooked up, you're going correctly to the GPIO line, and so on. And you can do that with both switches by reading 4 and 5. Okay, and you don't need a witness on that one. You don't need a witness on any of these except the last experiment. So that's your setup. That gets your board working correctly. Experiment 2, you're going to write a bash script, and your bash script should initialize some internal variable. You can think of it as count. Initialize that to 0, and print out the value of count repeatedly. Okay, so infinite loop just keeps echoing $count, but inside that loop, check the value of your 2 inputs. And if you find that either button is pressed, either increment or decrement count. Okay, if the up button is pressed, set count equal to count plus 1. If the down button is pressed, set it to count minus 1. And just keep echoing that variable forever. So there's lab 3. It just keeps printing out zeros, right? But if I press this button, it decrements my count. And if I press this button, it increments it. Right? If I don't press anything, it just keeps printing the same value. And you notice it increments and decrements by more than 1 at a time. And if you're like really good, you might get it to go by 1. There, I got by 1. But in general, right, we have multiple clicks. So why are we getting multiple clicks when we're only pressing the button once?
Because it's reading it very fast.
Because it's reading it very fast. And the other problem is these switches are mechanical, they're noisy, right? So when you press and release, it actually makes and breaks contact a bunch of times. But the main problem is that, you know, if I just hold a button, it just keeps checking it. And so that's the feature / bug. All right, so that's a lot of fun. So that's experiment 2, right? And it's really just a bash script. Initialize a counter, infinite loop prints it out, but inside that loop, check your 2 inputs, GPIO read, and if either one is pressed, increment or decrement. Okay, experiment 3, you're going to modify this so that it only displays the value of count when it changes, right? So instead of continually showing the same number again and again and again, it's only going to show it when it changes. So what does that look like? There's a 0, and it hasn't changed, so it's just showing a 0. So if I press the up button, or the down button, it changed to -4, and it shows me that. And if I press it again, right, and if I press the up button, and if I hold the button, it keeps changing, so it keeps displaying. But once I let go of the button, the value is not changing. Don't keep showing 45, 45, 45, right? So how do we make that happen?
You could use some if statements that checks the value of the pin in that's inputted.
Okay. What else?
Inside the if statement, you would print as the value of that pin, and it continuously loops until the value changes.
Okay. Could use a while loop. Some kind of loop, though, right? So how do we know if a value changes?
It's either 1 or 0.
So we see a 1. How do we know if that's different?
We store the previous value with your number.
Store the previous value. Okay. So we can do this a few different ways. We can see when the button changes, right? And we can monitor the up button and the down button, and if they change, we can adjust the count. Or we could monitor the count, right? Same effect in the end. So here's one way to think about this. So is our count equal to the old value of the count? And if it is, then we're just going to skip these parts. But if the old value of the count is different, then we want to display the count. And then we want to remember what that current count is that we just displayed. And now we can continue. And what's our main thing? is the up button pressed? If it is, increment count. Is the down button pressed? If it is, decrement the count. And then go back there. It looks slightly Halloweenish. Right, so something like that. If you've done 270, you did this in your first 270 lab, right? When you wanted to output when the switches were changing. Yeah.
What happens if you press down both buttons?
Then it doesn't count because it increments and decrements, and that can be a feature or a bug, depending on how you market it. All right, so does this make sense, right? Basically, you're checking the buttons, you're adjusting count. But before we display count, we see if it's different from the previous value we displayed. And if it is, we display the count, and we save the count we just displayed in that variable old. And so the backstory here is old is always the last value we displayed, right? That's an uppercase comment I'd probably put in my code so that when I'm trying to figure out, should I look for old, should I look for old plus 1, right? I always know old is the last value we displayed. So if we're about to display count, just see if it's different from old. If it's not, we've already displayed its value. Skip the echo statement. Otherwise, display it, and then remember what the value is. But there's, as usual, lots of ways you can do this. And yeah, if you press both, nothing happens. If you press one, it repeats. Did that weird anybody out? Like why it's cycling? It's just clipped. All right, so that's your third experiment. Okay, and that's just adding in one step in there. Okay, so the fourth one is to debounce it, and this is the one you're going to demo to get signatures on your sign-off sheet. So you'll write a third script, does exactly the same thing as the previous script, but we don't want it to just keep incrementing wildly when you press the button. So you do that by just throwing in a sleep statement. You can throw in a quarter of a second sleep by saying sleep 0.25, and if you put that in after you echo, that will clean everything up. So don't do it before, because then you have to wait to see what the output is. But as soon as you've displayed somewhere in here, just say sleep 0.25, right? Like that. And that will fix this up. So let's run lab 3C. So there's a 0, and that counts down nice and cleanly, and that counts up nice and cleanly. But still, if you hold it for more than a quarter of a second, it's got an auto repeat. Make sense? So that's your whole goal, is get to that. And it's not a long, right? So I put comments in mine. It was 39 lines of bash, but it's not shouldn't be daunting. It's nothing like high-low. But you know, if you get really crazy, you could build high-low out of this. You could put in 3 switches and have a button for high-low or correct. You could like play high-low with buttons instead of typing. That could be cool. All right, so your sign-off sheet, right? So 3 things to demonstrate. With no buttons pressed, it's not printing anything other than the initial count, which was 0. If you press up, it increases to the next number. If you press down, it goes down to the next number. Right, so just demonstrate that, get a witness signature, put that in your lab report, you're done. Questions? All right. So any questions on the ODP that you just finished? Pretty straightforward once you figured out the details. And like I say, this is a kind of common theme. Right, this idea of having a pair of pointers that don't necessarily move in lockstep. In this case, we had one pointer, we had a pair of input pointers that are always the same, but if we're doing something different, like I left you with this question of removing letter X from a string, right? So there you've got an input pointer and an output pointer, and they're not the same value. But it's the same idea, right? We use one to read and the other to write, basically. No other questions? High-low questions?
What was your high of the week?
What was my high of the
Yeah,
week?
point.
Oh, week's not over. It's a good question. My image processing system is scaring me, which is good. Gave me goosebumps on Sunday. Because I trained. So how many people here went to my talk or saw the video? So I have this weird alternative computing system. It's called Exist with 2 E's. And I've been training it on image recognition, so I've got a database of faces, and showed it 2 subjects, 5 different poses, and it can figure out, if you show it a picture, is this subject 1, is this subject 2, right? So I finally tried it on out-of-sample data, so I took 10 new pictures, right, of the 2 subjects, 5 poses each, sleeping, different lighting, frowning, surprised look, winking, right, and showed it those 10 pictures and asked it to tell me, is this subject 1 or subject 2, and it nailed it. And I haven't taught it anything about pictures, about faces, about expressions, about lighting. This is just raw processing going on, and it's able to do this differentiation, which is a little creepy to me. But I think I understand how it's doing it now, and the explanation is a little creepy too. So that's ongoing, and this afternoon I'll actually be like reworking that code. And there's a student in the other section who is porting this system. Well, he's already ported it to C, and he's porting it to a GPU with 3,800 cores on it, and getting some like really, really fast execution times. So this stuff is running on a cluster out of Virginia Tech, and it takes about 5 days to get results. And his system, I think we can get it in like a few minutes. So it's going to get creepier even faster. So that's been a bit of my highlight. All right. I don't want to jump into something new here because we only got about 15 minutes, but let me take this as an opportunity to start talking a little bit about VI. And I'm not going to test you on VI. Okay, I'm not going to insist that you use VI at all. But I want to just kind of like go over some things in VI that may make your life a little easier. And again, if you don't use these, that's perfectly fine. So let's VI, haha. So most people seem to use the arrow keys to move around VI, so up, down, left, right. Those are kind of like alternative ways to move, but the sort of official way to move in VI is H, J, K, and L. And they're right next to each other on the keyboard. And H goes to the left, J goes down, K goes up, L goes to the right. I don't use L, I use the space bar to go to the right, but L will work officially. So I can go space, I can go H, I can go J is down, I can go K is up. And it's no different from the arrow keys, except not all setups of VI understand arrow keys. Sometimes it gives you crazy backslashes and stuff. But H, J, K, L always work. And they also work for games like Rogue and stuff like that. But if you want to move around quickly, you can do Control D and go down half a page. You can do Control U and go up half a page. And that's a little faster than like hitting the down arrow key and waiting for it to repeat and so on. So Control D, Control U. You can also do Control F and go forward a whole page, or Control B and go back. And that's a fast way to get around. You can also say, these are things I have in muscle memory and I don't really know what they are. Okay. So you can type a number followed by a G, and that says go to whatever that number was. So if I compiled my program and I got an error at line 38 and I want to get to line 38, I can type 38 and a G. I just did a big G. Yeah, that's a big G. So you can type 38 and a big G and it goes to line 38. And if you hit Control G, this will show you info about what line you're on. So I hit Control G and it said I'm in column 1 of 64, line 38 of 221, word such and such of such and such, and so on. All right. So I can go up a few lines and hit Control G, and now I'm on line 35. And if you just hit a Shift G without any number, that takes you to the end of your file. So G, go to last line. If you want to go to the first line, you can just type 1G, because you know the first line is 1. But you don't know what the last line is, so you just hit a Shift G and it takes you to the last line. So it's easier to move up and down through your file like that sometimes. There's also easier ways to move through a line instead of just using the arrow keys. So you can use W, which means go forward one word. You can use B, which means go backwards one word. So if I hit a W, it starts going word by word, and words are separated by punctuations or white space. And it'll roll over onto the next lines, and I can do a B to go back. And I can also go to the beginning of a line by hitting a 0, and the end of a line by hitting a $sign. And these are probably pretty random looking, right? These are just the commands that I've ended up using for a few decades now in VI, and so they're useful to me. But there's, a zillion commands in VI. I don't like having to hit keys a bunch of times, but I really don't like having to wait for my computer. So if I'm over here and I'm trying to get to the end of a line, and I hit a space and I have to wait for it to get all the way over there, that just drives me crazy, right? So I learned I can hit a $sign to get there, and so I use that.
You do this nifty thing where you can replace words with other words. How do you do that?
Ah, okay, cool. So let's do some editing. So, so there's a CW, which is change word. So if I get to running, I can say CW. It displays a $ showing me what the end of the word is, right? And I can say, let's change it to if not going. So I'm in insert mode now, right? So I hit an escape, and now I just changed the word running to going. And I can word over here, and maybe I want to get rid of do and change that to going also. Well, you can always hit a period, and period repeats your last command. So I hit a period, it changes that to going.
Only that instance of the word or any instance?
That instance of the word. Because I said hitting a period is basically like saying CW, going, escape. So anywhere that I am, if I hit a period, right, if I hit a period right here, it'll change that to the end of the word to be going. So period is really useful. And it's useful, for example, if you want to delete a line, you can hit DD. 2 Ds. That deletes a line. And if I hit a period again, it's going to pretend that I just hit DD again, so it will delete this line with a comment on it. And if I hit period again, it'll delete that. And I can just bang on my period key and delete my whole file if I want. And I can only undo one.
How do you undo?
U will undo, but it depends on your setup. So U is an undo last command. But in that maddening way that is Linux. So let's say I delete this word with a DW, and I want to undo it. I can hit a U and it undoes my delete. If I hit U again, it undoes my undo. Right? So you only get sort of one level of right? But if you hit an uppercase U, it will undo everything on your current line. So an uppercase U brings you right back to where you were, but only on your current line. Right? So if I go to a different line and I hit an uppercase U, I can't come back to this line. And yeah.
Can you go with the problem, please?
Yeah, let me get to that in 1 second. So CW is a change word, DW is a delete word. So suppose I delete this line, right? When you delete it, it goes into a copy buffer automatically. Right? When you delete anything, a character, a word, a line, a bunch of lines, it always goes into a copy buffer or a paste buffer. And if you hit a lowercase p, this says paste, whatever is in your buffer. Well, I just deleted a line. I can come down here to the bottom of my file and I can hit a lowercase p and it pastes that line right there. Or I can say DW to get rid of alias and go to the end of my line and hit a P, and it'll paste it right there. Okay, another good one is little o and big O. And these say open a new line. Little o is below. Big O is above. And I know you encounter this, you're sitting up here and you want to start a new line of code right below here, right? Instead of going into insert mode, going to the end of your line and hitting an enter, right? Just hit a little O and it opens up space for a new line and you can start typing in there.
Does O take you into insert mode as well?
Say again?
Do you have to click I after O? Or does
Nope,
it
it puts you into insert mode. And if you're on the first line, you want to put something before the first line, you can just do a Shift-O, and it opens up. And it doesn't matter where you are in this line. You can be sitting here in the middle. Shift-O opens a new line in insert mode, puts you in column 1, and you're ready to type. All right. Next really cool thing to know about VI.
What do we can say? Say.
: So : W writes, : Q quits without writing, : WQ does both, and an exclamation mark says force. So I delete a bunch of lines and I don't want to do this. I can say : Q, it'll say you haven't written your changes yet. If I really wanted to quit, I can say : Q exclamation mark, and it'll go ahead and quit out. Yeah?
Is there really any difference between WQ and X?
I've never used X, but I think it's the same thing. Yeah. Is it like Shift X?
No.
Just an, oh, : X?
Yeah.
Shift X encrypts your file.
Yes.
Okay, don't do that.
I thought it was a capital X.
Capital X.
Yeah,
Yeah.
shift capital.
Okay.
Capital X.
Yeah, I think : X is probably just a short version of WQ. All right, so a number followed by a command repeats that command. And this is possibly the most useful shortcut. So I'm up here at the top. Suppose I want to delete 5 lines. I can say 5DD, 5 lines gone. Let's say I want to move over 6 words. I can say 6W moves over 6 words. And you can do this pretty much anywhere you want. If I say 25 insert haha escape, it repeats that insert haha command 25 times. Right? So this number is pretty universal. So if you want to copy and paste, here's a quick way to do it. Say I want to copy these 3 lines at the end of my file. I can say 3DD, I can say U to undo that, I can do Shift-G to go to the bottom, and I can say P to put those lines there. There's other ways to copy and paste. There's a yank command that'll put it into a paste buffer without deleting it. But that's a quick way to do it.
What's DD again?
Delete a line. Shift-D is a delete to the end of line. So if I want to get rid of this pipe over here, right, I can just move to there and hit a Shift-D. Then I could add my closing quote and be done. And there's other things, but top of my head, those are probably 80% of the biggies. You can do a Shift-J to join lines together. So this will take the line below and put it on your current line. J for join. So if you do 100 Shift-J, it turns your whole file, first 100 lines, into a single line.
That's scary.
That's pretty weird, and you can do a U to undo that. Or you can bang on U and get the little light show. So that's so my suggestion with these is, don't memorize these. You're not going to be tested on them. But if you're always doing something that's taking you a lot of time or distraction, if you're always trying to get to the end of a line by using the arrow key, and you can remember, oh wait, there was something we did in class that got us to the end of the line, right? check out your notes, make a note of it somewhere, stick it on a Post-it note somewhere, hit a $sign, right? And the ones that you end up using, right, you'll remember. And the ones that just don't work with the way that you code or type, don't worry about them, right? So we'll spend some more time with VI. In particular, we're going to talk about how to do things. When you hit a colon, you get into a whole another environment where you can do pretty major editing using regular expressions and things like that. So we'll be coming back to this, but Good Friday end of class topic. So take it for what it's worth. I will see you next time.